Number two, what is meant by ideal conditions relative to stoichiometric calculations? So we're talking about stoichiometric calculations. So when we are talking about stoichiometric calculations, what do we mean when we say ideal calculations? We throw that term around a lot. Ideal, theoretical versus real, actual. So when we say ideal conditions, when we say theoretically, what we are saying is we are assuming that the limiting reactant is completely converted to product with no losses. Perfectly, exactly as dictated, as dictated by the ratio of the coefficients, right? Exactly dictated by the ratio and the ratio alone. The limiting reactant is completely converted to product with zero losses. This is ideal. Does this ever happen in real life? No, it does not. So this is the difference between ideal conditions versus real conditions. Remember, in real life, ideal conditions are absolutely impossible. We have gone over, your book talks about a couple of different reasons why this is the case. There are reverse reactions going on where some of the products are actually turned back into reactants. There are side reactions going on. There's going to be some amount of impurities in the reactants that you measure out, regardless of how much money you pay to get the highest grade reactants. There's always going to be some amount of impurity because, well, perfection doesn't exist in this world. And so, as hard as you try, good on you, you will never achieve the ideal stoichiometric calculation in real life. Which will lead us to part B. What function do ideal stoichiometric calculations serve? If they never happen in real life, what good are they? Why are we talking about them? Why do we study them? Why do I have to do this in this class? Well, to be very, very functional, very, very practical, they determine the theoretical yield of the products of the reaction. And in this class, we have to calculate percent yield. And in order to calculate percent yield, theoretical yield is a requirement, right? That's the denominator of that fraction. And so having the ideal stoichiometric calculation allows you to generate your theoretical yield. Part C, speaking of actual yield, are actual yields typically larger or smaller than theoretical yields? They're smaller. Remember, they're those three things that we just mentioned, possible reverse reactions, possible side reactions, impurities in the reactants. Those are all reasons why your actual yield will always be smaller than your theoretical yield. Now, to be complete here, there may be something else going on that you're unaware of that would actually make your actual yield larger than your theoretical, but that's ridiculously, astronomically low probability. So we're going to stick with your actual yield has to be lower, smaller than your theoretical yield.